What's good, YouTube? It's Alma with the Sauce, and I'm back with another video. This video right here is the first video of a series of videos that I'm going to be doing where the ultimate goal is to figure out how to graph the sine and cosine functions. So you'll get to see how to graph them and why they look like the way they do. But the first part of this series is going to be talking about special right triangles. And it may not make sense now, but you'll soon see how all these videos tie into the ultimate goal of the series. So get your pencil, get your paper, and let's get into it. All right, so the first type of special right triangle that we're going to talk about is called the 45-45-90 triangle. All right, so the 45-45-90 triangle looks like this. Obviously, the numbers refer to the angles inside of the triangle. And so the goal of this video is to basically figure out how long each of the three sides are. So here's what I'm going to do. If we let one side of this triangle be x, I'm going to show you how to figure out how long the other sides are in relation to x. So before I start to talk about how these sides come about, I'm going to give you a little visual just to help make everything clear. So it does sound weird, but just trust me. All right, so imagine, like, you know how an alligator's mouth goes, open and closed. So if you can picture attaching like a rubber band from the bottom of the alligator's mouth to the top of the alligator's mouth, you can understand that, the wider he opens his mouth, the longer the rubber band is, right? So if his mouth is almost closed, the rubber band is really short. All right, now I know it's kind of a weird visual, but it'll make sense in a little bit. So back to our triangle, if I let the side across from this 45-degree angle be x, think of this as like the alligator's mouth. And so it has a string or a rubber band of length x, right? If I look at this side down here, it also comes from a 45-degree angle. So it's basically the same length as this side right here. So if this side is x, then hopefully you can see how this side is also x. All right, and so now what I'm about to do is figure out how to come up with the length of the third side using the Pythagorean Theorem. If we have two sides, we can solve for the third side. All right, so Pythagorean Theorem tells us that one leg squared plus the other leg squared equals the hypotenuse squared. So that's what we have here. Think of this as like my A, my B, and then I just let that be C. And so what we're trying to do is figure out how long is C in terms of x. So if we're trying to get C by itself, we can simplify this side. X squared plus another x squared, that'll just give us 2x squared equals C squared. All right, so now if you remember your properties of radicals, you know that the square root and the squared are inverse operations of each other. So if you do both of them to one thing, then they're going to cancel out. So if I square root the right side, you already know I got to square root the left side too. All right, so now since the square root and the squared are gone, I'm just left with C on the right side. So C is by itself. So now we can just simplify the other side. If I have the square root of a product of something, I can rewrite that as a square root of the two products separated. And so again, I have the square root of something squared. So that just leaves me with the square root of 2 times x equals C. All right, and so if these two sides are x, then the hypotenuse is going to be the square root of 2 times x, but conventionally we like to write it like this with the radical coming last. All right, and so basically if these two sides are x, then the hypotenuse is going to be that same x but multiplied by the square root of 2. And so that's kind of how that comes about. I know a lot of teachers like to just give it to you and be like, all right, memorize it, but I just wanted you to see how it came about. All right, so the other type of triangle we have is called the 30-60-90 triangle. So again, I'm going to do it the same way, kind of similar to how I did the last one. We're going to let the side across from the 30-degree angle be x. And if this side is x, we're trying to figure out how long are the other two sides in relation to x. So for this one, the way you go about it is a little bit different. So what I'm going to do is I'm going to take this 30-60-90 triangle and basically reflect it across the dotted line. So I'll then have two identical triangles. So if you've taken geometry, one of the properties of reflections is that the pre-image is always going to be the same as the image. Think of it like your reflection in a mirror. You're the exact same size as your reflection. So what that means is everything that's true about this triangle, the properties are the same in this triangle. So if this side is length x, then this side is also length x. If this is a 90-degree angle, that's a 90-degree angle. If this is a 30-degree angle, then that means this is also a 30-degree angle. And if this is 60, then this is 60 down here as well. One thing you might notice is that it creates one big triangle. And if you look at the angles of all the triangles, you might notice something. If I'm looking at this angle right here, this angle right here, those are both 60. And then these two 30-degree angles add up to make another 60-degree angle. So again, think about that alligator reference that I made earlier. If all the sides are coming from the same angle, then that means that this side, this big side, and this side right here all have to be the same length because they're all formed by the same 60-degree angle. So if you're looking at this big triangle, and if I have this side of length x and this side of length x, then that whole entire side is going to be 2x, right? You're just putting those two x's together. And like we already said, you know all three sides are the same. It's an equilateral triangle. So that means if this side is 2x, then that means this side is length 2x as well as this side. All right, so now what you have is, looking at our original triangle, you have this side x and you have this side of length 2x. And so at this point we have 2 out of the 3 sides. And again, we can use Pythagorean Theorem to find the length of this third side. All right, so what I went ahead and did is, you know how it's a squared plus b squared equals c squared. Think of this as your a. I went ahead and let this side be b, and then our hypotenuse is 2x. So using the Pythagorean Theorem, it'd be x squared plus b squared equals 2x squared. And now one thing to be clear about is we're squaring that whole quantity 2x. So there has to be parentheses right there, otherwise it'll get messed up. And so what we're trying to do is basically, again, figure out how long is this side b in terms of x. We're just basically trying to get b by itself. All right, so before I solve for b, I'm gonna go ahead and simplify this right side to make it a little bit more clear. Really, I have x squared plus b squared equals, now 2x times 2x is gonna be, the 2 times 2 is a 4, and then the x times x is gonna give me an x squared. So that's really what I have. And then, you know, I can subtract x squared from both sides. Reminder, I'm trying to get b by itself. All right, so that's gonna give me b squared is equal to 4x squared minus only 1x squared. That's gonna give me 3x squared. And then again, just like last time, if I wanna get b by itself, I have to take the square root of b squared. And you already know, if I square root the left side, I gotta square root the right side too. So really, b is gonna be equal to the square root of 3 times the square root of x squared. But you know, this is just x. So really, b is gonna be equal to x times the square root of 3. Remember, we like to leave the radical part last. All right, so what we just found out is, if this side is x, the hypotenuse is 2x, then that other leg is going to have a length of x times the square root of 3. All right, and so I just wanted to show y'all where these side lengths came from. We're going to use these two triangles and their side lengths in the future video, so stay tuned.